Good morning and welcome to STEM Ambassadors Live. And this morning I'm with Molly Robison. Molly works for MBDA. Her job title is Graduate Climatic and Environmental Test Engineer. And she's going to talk to you about the forefront of defence and future weapon capabilities at MBDA. So I'm going to hand over to Molly now. Thank you very much.
Hi everyone, I'm Molly. So I'm the Graduate Climatic Environmental Test Engineer. It's quite a long title, but it involves quite a lot of different things within the test engineering of missiles. So I'm just going to begin a little bit about my journey into where I am today, because it's a little bit different to your typical A-level route. So I'm just going to start off with, I began in high school, so this is like when you're about 16, doing my BTEC in general engineering. And that was kind of when my interest started to really blow up. I was like, okay, engineering is definitely what I want to do, but I'm not too keen on continuing with A level. So I actually went to college and did a level 3 aeronautical engineering course. So across the 2 years, I got involved with quite a lot of practical exercises. As you can see at the bottom photo, we got to work on like real engines and learn how to pull them apart and put them together for like assessments, as well as do your typical theory classes like your maths and mechanical systems, mechanical science. And it was really building up the foundation of my excitement towards engineering, and especially towards the engineering aerospace world. So in that aspect, they were actually training us up to be aircraft mechanics, which is really cool. But I really wanted to explore what I could do with engineering just a little bit more. So I ended up going to university and completing my degree in aerospace engineering with management. And it was quite a long 4 years, and it was a mix of a lot of theory and a bit of practical all in one. But it was a very exciting journey to be a part of. I got to meet a load of different people from different companies who would come and visit my university for talks, as well as take a year in industry. So during my 3rd year, I decided to not go to uni and go to work instead for 1 year. And that was at Marshall Aerospace up in Cambridge. Now, they're a very exciting company. They get to work with C-130 aircraft. These really, really big aircraft that are used for search and rescue and to deploy our troops out in different countries. Now, these aircraft need to be maintained. They need to have upgrades. And that's pretty much what this company did. So across my whole year, I spent 6 months in the design team doing minor modifications for the aircraft, which was really cool because I got to put together my modelling skills that I'd learned at CATIA at university and lead a project from start to finish. So that's where my management came into handy there. And then the final 6 months was test engineering. And this is where I'd finally decided test engineering is what I'd like to do for my career. I really enjoyed my time on the test team, doing a lot of structural testing with the aircraft. So it could be as simple as bringing in like a little part of the aircraft and pushing down on with using actuators, which are like big, huge push buttons really, and continuously putting on this movement over and over again to see where the point of failure was going to happen. And if there was any sort of visual aspects that would help us determine, okay, it's going to fail after X amount of hours or under X amount of pressure. And we were able to replicate that for aircraft vehicles. We were able to replicate that for the sea vehicles as well as land vehicles. It was a very, very exciting time. So after I'd finished my year in industry, I went and finished my degree, and I graduated in 2020, which, as you might know, wasn't the best year for finishing the degrees. So it was a little bit difficult to get jobs at that time. But I decided I'll go and see what's about. And I ended up at GSK, which is a massive, huge pharmaceuticals company. There's a base actually here in Stevenage as well and where. And I worked there for about 8-9 months as an assembly operator, keeping the machines going and making sure that we're producing all the inhalers that GSK are very known for. It was quite a tough job because these machines are very demanding. They do have issues, so I got to put a bit of my engineering ability together there. But it was quite nice to see how the pharmaceutical industry worked. Very different from engineering, very tight on their regulations. But overall, it was an interesting area to see, considering at this point I've been doing engineering for about 6 years. But in the end, it was engineering that I've always wanted to go back into. And I started looking again at what test engineering jobs were available. And I was very grateful to get onto the graduate scheme here at MBDA. So just in that little picture there is me and my colleague. We're working on setting up a test. So that's a big, huge container that's sitting on these shakers. Now these shakers are very, very clever. We can input a signal from a computer and these shakers will start vibrating up and down very, very quickly at a very high level, which is known as GRMS. And that could be up to 10, 20, 30, all the way down to about 2. And as it's shaken, the container feels all of this. And there's tiny little accelerometers stuck to the container inside and outside, which pick up these signals and the vibrations happen inside the container, and which we can see live on a computer. And as the data's coming through, we get to analyze it and we get to find out what's really happening, even though we can't see it with our eyes. So when the data comes through, there's like these really huge spikes, and they're the areas of interest. We're trying to figure out why those big spikes happening. Has something snapped inside? Has any of the materials delaminated? Have those clasps come off, for example? Has the unit inside just come loose? So there's loads of different things we've got to think about. It's very high up on the problem solving area of the job, but it's very, very interesting. So I'm just going to dive a little bit more into that for you. So testing is a lot of things. The activities involved help engineers find acceptable levels of vibration an object can survive. So every day an object, whether it be your pen or the car that you drive in, will feel little waves known as vibrations, and those waves travel along a load path, which can cause a lot of stress on the object, and eventually that object will see different types of failure. So MBDA, we take these units, these objects, and simulate real life environments, whether it's a big aircraft traveling in the sky where it's negative 56 degrees, or down on the ground with a truck that's zooming around at 60 miles an hour in the sand. We've all got to be able to replicate this in our buildings at work. And we do that by using the shakers like you saw in the photo before, and massive, massive temperature chambers. So if we took an example from a little diagram in front of you there, we have shocks. So the shocks are big, huge levels of GRMS, probably about 50. And all the shaker does is they send that one at a time, maybe with a 5-second gap, right into the unit. And it could replicate an accidental drop of the container. It could replicate gunfire. It could replicate the helicopter when the rotator passes its 1 revolution. That's all of the shock data, because eventually that container will feel it to some degree. And if we take it to a different test, so high and low temperature, inside of our big chambers, we can control the temperature from as low as negative 60 degrees all the way up to like 70 degrees. And that's just to try and simulate the different environments that you see around the world. And we need to know our units will survive the temperature. So we will perform operational checks to make sure all the electronics and the smart brain switches on, even after seeing itself for 70 degrees for 6 hours. It's quite an intensive area to work in, but it's a lot of fun because, yes, things can go wrong, but it's the problem solving and the critical thinking that makes the job really, really exciting. So I'm going to show you a very little example of what we do here. Just because obviously I can't show you what we do in the house. So what's happening here is that I'm sending electrical signals into a mini shaker, which is creating those vibrations, those waves through the plate, and moving the sound into that pattern. Now, that pattern that you can see, so those like 4 corners of the stars, are known as resonant frequencies. So when a material vibrates at its highest amplitude, much like when a singer can break a glass with her voice, you can see failures happening, and that happens inside of our objects as well. So when we're shaking everything, these resonant frequencies, which are those high peaks on the graph that I mentioned before, that is happening right there in real time. And this is how that's a good way of showing you what's happening visually, rather than just obviously me trying to tell you. And pointing out these resonant frequencies will help us find our failure points. So we could go to a customer, maybe don't operate your aircraft at that high of an altitude because this could happen. Or it could go back to the design teams and be like, could you potentially strengthen this area with a new material or change the design so it's not as critical of an angle potentially? And it's just to try and make sure we're not going to ever hit those resonant frequencies. So I've only shown you a very small portion of what MBDA does. We have so many teams that spread across software engineering, general engineering, and business. So there's a lovely little spreadsheet here, shows you different areas of opportunity. So we have teams in commercial who work on your sales, and they talk to the customers and try and convince them to buy things from us. We have our electronics teams, we have human factors, lethality, project management. There's so many different teams that you can be involved with if this was a company you would like to come and work for. So how could that happen for you? Well, we have many different programs that are available to a lot of students of different ages. So for your work experience program, which is aimed at year 11 to 13 students, you can come and work for us for 1 week, and you work alongside loads of different engineers from different departments and just get an insight into their job, what it's like to be them for the day. And you get to build on some key skills for the future. It's very, very interesting, and it's really good experience to take with you if you do an apprenticeship or you go and do your degree. People love to see it, and people love to listen to you about what you got up to. Now, our apprenticeship schemes are aimed at school leavers, so this is after you've done your A-levels or gone to college, and it's a 4-year programme that will let you work across MBDA in, again, many different departments. And while you're there, you also get your university degree that's tailored to the department you joined. So if you were to join my test team, for example, the apprentices undergo a mechanical engineering degree. If you were really interested in software, it would be a computing degree that you would do. The best thing is you are paid for your apprenticeship scheme, and your degree is paid for as well. So it's a fantastic opportunity to come and work in the office for 4 days and then go to university for a day and build up that experience and really get to learn from the company firsthand. Now, if you're like me and decide, you know what, I would like to go to university after A-levels, that's completely fine. We have 3 really awesome programs for you to be a part of. So if you're in your first and second year, you can join our summer placements, which is 10 to 12 weeks in the summer, and you'll work within a team on a real life project, and you get to do some proper work and present it at the end and tell everyone this is what I did. And it's a fantastic opportunity for you again to get some experience, maybe some practical hands-on stuff that university might not offer. And then following that, if you really, really loved it and you want to do a year in industry like I did, which I could highly recommend because you get work experience that employers absolutely love to see once you've graduated, we do offer the same. It's an undergrad placement, which is 10 months long. Same principle, you work within your team on rotation, and you just get to work on some projects, some really, really cool stuff. We're not going to put you aside and keep you in a corner. We're going to bring you out. We're going to get you on stuff and really put your strengths to the test. It's a lot of fun to do. And then finally, quite a long way off, but if you go to your degree and you finish and you graduate and you're like, time to start working, we do also offer our graduate scheme, which is what I'm a part of. And that is a 2-year scheme, or 3 years if you're in finance. And across those 2 years, you will spend 4 placements, each are 6 months long, within your department, one of which is external, and you can go absolutely anywhere in the company. So if you were in general engineering, but you really wanted to see how business is done and see how you talk to customers, you can go and do that for 6 months. Or if you're in software, but really wanted to have some practical hands-on of working on the missiles, you can go and do that as well. Because the thing that we like to stand by is that we're creating opportunities for people like yourself so it can benefit your future and help support finding what you really, really enjoy, which was what I got out of my undergrad placement. I found out it's not designing, that's not for me, but it's definitely testing. So that is it for my presentation. I hope you've enjoyed learning a little bit about missile testing and what we do here, and as well as the other departments that we have. Yeah, and if you have any questions, you can ask away. But thank you for listening.
That was great. Thank you ever so much for that, Molly. Really interesting. I'm going to stop the recording.